Okay, this is video 1 for the drivetrain unit notes. For this this unit, I want you to be able to explain the purpose of a differential gearbox, calculate the mechanical advantage of a warm gear system, calculate the mechanical advantage needed for a lifting system, and design for turning torque and turning scrub. So, in this first video, we want to start talking about gearboxes. So here I have a few animations showing a differential gear system here. So this first part right here comes from the motor. So that's like your input. And what this does is it uses planetary gears for this system. So in the system right here, the yellow shafts represent where the wheels go. This blue gear here is permanently attached to that drive shaft. So what happens then is you can have a mechanism that as this turns, we have these other planetary gears inside that can turn the other shaft. This animation down here might be a little bit easier to get a visual for. So again, here this comes in from the motor. And we can see how these three planetary gears operate. The purpose of this differential is basically it helps us allow each wheel to turn independently of the other wheel. A good example of this, if you've ever driven a four-wheeler, four-wheelers do not have differential gears. So when you go to make a turn, both wheels spin at the same speed. So when you go to make a turn, the inside wheel, because it has a shorter distance to go than the outside wheel, it's traveling at the same speed as the outside wheel. So what happens is you end up tearing up the grass on that inside wheel. So the differential allows us to have the wheels spinning at different speeds. This is really nice for cars. If you did not have a differential gear system in a car, every time you make a turn, the car would kind of hop and jitter as it goes around the turn. There are special devices, lockers or like limited slip differentials that manufacturers make that help lock up those two back wheels if you're in like a four-wheel drive situation and you need power evenly to both wheels. But the purpose of the differential is to allow the wheels to go at different speeds. So down here I have a diagram for a car. So what we have is we have our, coming in from our transmission or motor, going out to the two wheels. And again, this large crown gear is permanently attached to one of your drive shafts. So typically when you're driving down the road, only one wheel is getting power from the motor. And then our planetary gears are inside here. What's kind of interesting, some people will do this, if you want to build up a drag race car, and you don't want to spend all the money to get a differential specifically for drag racing, you could weld these gears together. And when you weld these gears together, this crown gear also becomes permanently attached to that other wheel. So if you weld together those planetary gears, then basically what happens is that you lock up all that differential. The next topic is the warm gear. These have really high mechanical advantage. So basically, you cannot really use a warm gear to increase speed by itself. We can look at some examples here in a minute where we could increase speed, but basically the purpose of a warm gear is to really increase mechanical advantage. So this part right here is the warm gear, It's a helical gear, and it's spirals, and it has one tooth. There is no break in that one tooth. Now, with the worm gear, you have to use a worm wheel. A regular old spur gear will not work. If you carefully take a look at the teeth on this worm wheel, you'll notice that they are slightly helical themselves to match the worm gear. So you have to use a very, very special gear with your worm gear, or a special wheel with your worm gear. Then, when we go to calculate the mechanical advantage, this will equal the number of teeth on the worm wheel divided by the number of teeth on the worm gear. But remember, the number of teeth on the worm gear is always 1. So the mechanical advantage turns out to be the number of teeth divided by 1. So to calculate the mechanical advantage of a worm gear system, it's really, really simple. All you need is a number of teeth on the worm wheel. That's all you need. Now notice that this mechanical advantage is going to be something that will always be greater than 1. So whenever we have a mechanical advantage that's greater than 1, it's designed for torque and it sacrifices speed. However, what makes these really special also is that while the worm gear can turn the worm wheel, the opposite is not true. So looking at this example right here, we have a worm gear turning a worm wheel. If I were to grab a hold of that wheel, this tire here, and try to spin it, it would not spin. And part of the reason for that is that there's a tremendous amount of friction between the worm gear and the worm wheel. But the other reason is the mechanical advantage. You see, whenever your mechanical advantage is significantly greater than 1, the system becomes a brake. The system, basically, you can only go in one direction. We've noticed this probably in some of your lifting systems when you've designed systems that we have high mechanical advantage. The motor can turn the system very easily, but it's very hard to go the other way. So the nice thing about these worm gear systems is that they're one directional only. You can just go in one direction and you don't have to worry about the wheels slipping. So if you wanted to drive up a hill and then just turn the motor off, this would hold the system. Now let's take a look at an example where we have several things going on here. So in this one right here, we got our motor. Our motor is directly attached to a 60-tooth gear. The 60-tooth gear is attached to a 12-tooth gear, which on the same axle as that 12-tooth gear, we have a 60 that is attached to a 12. That 12 is then attached to a worm gear, which has one tooth, and then the worm tooth is attached to a worm wheel, and in the VEX system, the worm wheel has 24 teeth. And we want to go through and we want to calculate the mechanical advantage of this system. So I like to do output divided by input. So first off, I have 24 divided by 1 times, and then output divided by input, so then I have 12 over 60 times 12 over 60. So notice that for all of those I have output divided by input. And this is a compound gear train. When you plug those numbers in, you get the mechanical advantage of this system is 0.96. So this system is actually designed for speed and not torque. However, you would not be able to spin the tire in this system. There'd be too much friction between the warm wheel and the warm gear. So looking at this particular system then, I can go ahead and calculate the output rotational speed. So for us, the input speed, say it's a regular motor or default, and we get 104. So we get a slight increase in speed. And we get a slight decrease in torque. Honestly, this system has a mechanical advantage that's really close to 1, so we wouldn't have to, we would not be losing a whole lot. It'd almost be like sticking a motor on that wheel. But the advantage here is that even though the mechanical advantage is practically 1, we're not increasing speed, we're not really increasing torque. The real advantage here is that that warm gear would act as a brake. So once you turn the motor off, that thing is going to stay put. It's not going to go anywhere. All right, that concludes video 1.